Hello everyone, welcome to day 28 of our machine learning internship and I welcome you all. So in the past few sessions or in the previous few sessions we are discussing about time series analysis. Anyway, throughout this internship we started with the base of Python and then dealt with some machine learning concepts, exploratory data analysis, machine learning algorithms. So implementing the starting of basic projects of machine learning, different verticals of machine learning like classification, regression and so on. So after that we explored an introduction about deep learning, and with the help of deep learning we are trying to achieve some advanced effects in machine learning, like talking about time series predictions. We can do it with time series algorithms. Anyway, it's not possible with your normal machine learning algorithm. In such cases you can use your neural networks also and gain it through your deep learning. So that's what we have seen in the previous session. Also in this session, what in the last few days or from day 28 to day 30, in the last three sessions we are going to discuss about natural language processing, or simply called as NLP. So this deals with human language, how we speak, etc. And this is also going to be a type of data. Okay, we have already seen that what all the different types of data which can be available. Like for example, we can have image based data, we can have text data, not only numbers. Okay, so this text, if you somehow convert it into numbers, then you can work with it, right? So that is where NLP creates, and there are a lot of real-time applications right now everyone is using. We'll discuss about that, and we'll be giving some ideas and we'll be dealing with the base, because you cannot just be an expert in the last three sessions talking about NLP. We'll do the basics here. So if you are interested in particular domain like time series or NLP, you can take it as a career path to the next level after learning this machine learning course. Anyway, so starting with natural language processing. And natural language processing, also called as NLP, is a machine learning technology that gives computers the ability to interpret, manipulate and comprehend human language. What if a computer talks to me? Okay, then I can tell what I require and it can give me some outputs based on it, right? So we used to do it with programming language and everyone can't do it, and there are a lot of advances right now. So when I talk about NLP, one common example which I can give, which is one of the high level application right now. Okay, so you cannot directly just jump and build it anyway, but the thing is we can't ignore ChatGPT, right? So ChatGPT is one of the real-time and high-level application of NLP currently. Okay, it's the, like I can tell you, this is the topmost application which you can do right now, which is something like ChatGPT from OpenAI. So in ChatGPT, most of you guys have used it. So I'll be typing some prompts and it is giving me answers. So what is happening there? Okay, and you see, like everyone is using that. How it actually works. So I'll tell you some base about ChatGPTs, which can be a little bit thoughtful for you if you don't have any idea about it. Anyway, this is not covered in this course. I'll be giving you some introductions about a lot of new terms, and the projects we'll be seeing in the further sessions are some of the base level starting projects which you can start with NLP, which finally you can lead through something like this, a chatbot or an advanced version with neural networks is ChatGPT. So talking about ChatGPT, it's like a chatting engine, right? So it's like you are chatting with a human, so in that same format. And that GPT is actually, it's not just a random name from the company. They have given it particularly because it is consists of generative pre-trained transformers. So if you understand these three terms, then you can understand what ChatGPT is. So the G represents generative algorithm. So this is a generative one, which means if you are training in the data, you can expect it to generate something like a new one which is not from your previous data, okay, which looks like a real one but it's a fake one or created by your algorithm. We'll see what is the generative algorithms also here, an introduction. And this is pre-trained. You are going to train it. ChatGPT is trained on a huge amount of data, human language data. So it is even called as corpus, which is consists of human language data. And then finally the T represents transformers. And what this transformers is, so it is a type of neural network architecture. Once again, the base thing is going to be your neural network, but something like a CNN, something like a LSTM, this is actually a huge architecture which has a lot of components inside of it. Anyway, it is built of neurons and lot of other components. It's one of the high level application. I'll show you a graph of how a transformer works, what is happening there, etc. Anyway, to start with a generator or generative algorithms, so the start has happened with this algorithm, which is, you would have heard about this, about GAN. So it is one of the generative tasks. See here, generative adversarial network, GAN. And GANs are designed for generative tasks, meaning they are used to create new data instances that resemble your given data. Okay, so these are generative things. So a generative adversarial network is in a machine learning model in which two neural networks compete with each other. Okay, and to improve their prediction. For example, this GAN, right, it has two neural networks. So one is called as a generator, another one is called as a discriminator. And the core idea behind this GAN is to pit or make these two compete against each other. So one will be generating something, one will be validating it, like a thief and a police. For example, I'll tell you that example. So this generator is a CNN and discriminator is a deconvolution neural network. And finally, the goal of the generator is to artificially manufacture outputs that could be easily mistaken for real data. So your generator will be generating some things which are similar or resembling the original data, but they are fake. And the goal of the discriminator is to compare and identify whether it's artificially created or original one. Something like this. We have a generator algorithm, we have a discriminator algorithm. So for example, we are generating a new image. So the generator will be designing a Mona Lisa painting. So your discriminator will be telling that it is not same, it's fake. So now also it's fake. And then it is keep on improving. At one point it is same. Okay, so it creates some authentic or something which looks original. If it passes, it is a generated image which looks like same. So this can also be applied for text also. So your text data can also be generated like this. And this is one of the generative models evolution. And you can see this orange color we have is for NLP, this green color is for computer vision. And you can see your LSTM is here in the timeline, and then transformer showed up, then GP2 algorithms, then GPT-3 algorithms, now ChatGPT with GPT 3.5 and 4, and they are improving it furthermore, right? Also talking about this GANs, nowadays when you use Photoshop, you have an option for generative AI, where you can describe what you want or you can transform it in a click, right? So those all coming from here. So with the help of this, okay, now you know what is this G is about, generative, and pre-trained, which is trained on a huge amount of data. And finally this transformers is an algorithm. Okay, that is what this BERT is having a T there, GPT is having a T there. Finally that T is this transformer algorithm, and it started in 2017 with a publishing of a paper from Google. So attention is all you need. Okay, this is actually a research paper which started this trend on transformers. These scientists have worked on this transformer algorithm for a huge time, and they have developed something which is this is your transformer algorithm, which is the base for your ChatGPT working and all. So when you have your input, okay, for example, you are typing a sentence, it is embedded into numerical format, and then positional encoding is done, and then it is going into this head attention where a lot of processing will be happen, and then it is normalized and given to the forward feed neural network. So this is called as, okay, we have two boxes here, so this process will be given here. Okay, so we have a encoder and decoder. This is called as encoder, this one is decoder, so they work together. Okay, and so with the help of encoder and decoder, they'll train and then they'll give output. And this transformer algorithm you can learn once you are familiar with NLP and generative algorithms. You can learn furthermore about how this transformer works, or you can try to build that one also. And finally, this has been actually developed for language translation by giving some positional encoding and attention. Self-attention has been given. If you read this paper, that's why they have named it as attention is all you need. And yeah, that's about the transformer algorithm. And this is the data trained. Talking about GPT-1, GPT-2 and GPT-3 evolution, we have in different years it has been released, and the parameters it can handle, what's the training data it has been included, what's the training time, or how much layer etc is given here. and the transformers is having your input will be going to the encoder, and the features are taken and decoded and given the output. So this is the mechanism which makes your chat GPT works. And anyway, now what we are going to do is shifting towards our focus. Directly you can't jump and build something like a chat GPT. At first you can try to build a chatbot which gives the predefined response. If you have that in your word, for example, if you type hello, you can set like, if hello is present in my word, you can return this hi, I'm from, or any chatbot which is giving some chatbot responses. So that is different. Chatbot will be giving you a predefined responses, and ChatGPT is generated one, new one, and it is actually working very good nowadays. And talking about our steps here, what we are going to do is, if you want to start all of these things, or if you want to work in this domain, you need to have some base knowledge that we'll try to cover. For example, if I have text data, which is for every row I'm having text data, like a tweet. For example, every row I'm having a tweet data, and a column or output is whether that tweet is positive or negative. So it's actually a binary classification I want to do, so that when I type a new text, okay, new tweet, it should give me whether it's a positive one or negative one. And if you want to work on this, I'll give you a glimpse of what we'll be doing here. So first I'm having that tweet, okay, I need to take it and I need to process it and then convert it into numbers, so that I can give it to my algorithm once again, or I can give it to my neural network. So first, when you take your tweet data, it will be having a lot of unnecessary things also, like emojis can be there, hashtags can be there, okay, the username will be there, and unwanted connecting words, we'll see that. So those things we need to remove, we'll be removing it to reduce the complexity, we'll remove it. And then finally we'll be having a raw data or transformed data, which there are some processes we'll see here to convert it into numbers. And once I turn them into numbers, I can use it in any of the algorithm. If I have an array of numbers and their respective output, whether it's positive or negative, I can train my model, right? So in this session, we will be talking about how you can work with this library, which is NLTK, is called as Natural Language Toolkit. Is for NLP process in Python. This library will help you to do the pre-processing. We'll see that. And also after doing that, in the next session, we will be discussing a project which uses machine learning algorithm to solve the task. And then in the final day, we'll be discussing about a project which uses neural network to solve the problem. So we'll start with working with NLTK. NLTK is popular Python library which is nothing but Natural Language Toolkit, used for natural language processing applications to work with human language data. And what it actually do is, it will convert the text into numbers. It can help in converting text into numbers. So these texts are like human natural language. So we are converting them into numbers and giving them to models to work on it. And NLTK has a lot of tools such as tokenization, stemming, tagging, and etc. So we'll see about them later. Starting with the installation part. If you want to install NLTK, you can go with pip install NLTK, and then to import it, you can call import NLTK. And once you imported it, we have to download certain things from NLTK, so you can do it individually, or else it will be better to go with NLTK.download all. So inside the bracket, inside quotation, you have to pass all. So it will download everything. So then you will be getting no errors, no requirement required. So you are ready to go. We'll start this by installing. So in Colab, let me pass pip install NLTK. I'll run this. If you don't have it, will download. And then what you can do is you can import NLTK, Natural Language Toolkit. So once you are imported it, it is success, and you can call NLTK and use it. So first thing we are going to do is we are going to download all the necessary things. We are just going to download everything all. So this will take few time to download everything. And while it gets download, after it is done for me, so it may take few time for you. And once it is completed, we can start with the working NLTK. So for showing some example, I am having a sample paragraph. I'll paste it here. So this is a paragraph with many sentences and words. I stored it in the variable sample, and we are going to use this for today's practice with NLTK. And starting with tokenization, there is something known as tokenization in NLTK. Tokenization is the process of splitting a text into smaller units, and those smaller units are called as tokens. So we are converting into smaller units. So what are tokens can be like, the tokens may be like, there may be a words or sentence, okay? Like based on your task you can do it. For example, as I shown you, we are having a paragraph and I am converting them into smaller units. I can do that. I can convert them into words or I can even convert them into sentences, okay? Splitting them, that's what the meaning is. And by breaking them we can analyze and then do further processes easily, okay? And how we are going to do is, we are going to call nltk.sent_tokenize. So this will convert a paragraph into sentences. So each sentence will be a different string inside a list. And if you want to convert them into different words, okay, each word should be a token. If you wish that, you can go on with word_tokenize. This will convert everything into word, and each word will be element in a list. And we'll try to do this with our sample nltk. So I'm going to use this sample now. nltk.sent_tokenize. I have to pass the sample here. Let me create a variable to store this. Let me create sentences equal to nltk.sent_tokenize. I'm passing the sample. Let me run this. Okay, so now it ran. Let us print the sentence and see. See here, the first sentence is in a string. It is an element in the 0th index, and then the next is in the second index, first index, then second index. So it is separated by comma, okay? So each sentence is separated different elements. So this is how this sentences work, sent_tokenize. You can also find the length of the sentence. So how much it is splitted. So this is consists of 8 sentences, okay? And similarly, what you can do is you can convert them into words. I can call words equal to nltk word_tokenize, and this will convert the sample into words. You can also pause the sentence, it will also convert that. So now we will print words and see what is happening there. So it also will be a list, but it is combination of elements, like all the individual words will be element, okay? Climate change is one of the most, okay, everything is separate now, and you can find the length of it also. Totally 2 to 7 words are there in this, okay? This is how you can create tokens, and this will help us to convert them into smaller units so that we can do further tasks. There is something also known as stop words, okay? So what we are actually doing with this NLTK is we are going to analyze human natural language, okay? So like the natural language based on grammar, for understanding we will be having many much like unwanted, unnecessary, unimportant words inside it, like is, was, there. You see that in example, see here. We are having, right, is, of, the, like many words, repetitive words which won't be containing many much use in here. So those words will be called as stop words, which is present in NLTK. Those words are called as stop words. And stop words are words that occur frequently in a language and do not carry much meaning. Like a, the, and stop words are often removed from text using pre-processing to reduce the amount of noise. Okay, you cannot give directly everything to the machine. It may, like, the outcome may not be good, so that we are like trying to like short it as much as possible. And these words are available in NLTK stop words, and they can be used to remove from our data set. So if you're like, I'm having the sample, right, then I can compare, like I have converted into words now, and I can compare them, and if it is like a stop word, I can remove that. To open stop words, what you can do is you can call from nltk.corpus and then import stop words. We'll try to do this. nltk.stopwords, sorry, from nltk.corpus import stopwords. Okay, it ran. Now we can call the stopwords stopwords.words, and inside you can pass the language which you want to specify. I need stop words from English. I'll run this. So these are the stop words present inside corpus NLTK. I, me, my, myself, we, are. So these are the words which is available in stop words, and you can use this to remove in your sentence. If you have this in your sentence, you can remove that, and actually you can store it in a variable so that you can use it. And we can pass a set here. So what is the property of a set? The set will be only give unique elements and not the repeated element. So we can pass the set here and we can store it in the variable stop so that we can use it later. Stop equal to set words English. Fine. So now what we are going to do is, we are having our words, right? In my sentence, I am going to use the stop words which is present in this variable stop. I am going to compare. If it is a stop word, I am going to remove it, and if it is not a stop word, I am going to use it for further. Okay, I am going to filter it with the help of stop words, and to do that, I am going to create a new list first, an empty list for now in the variable new, and then I am going to call the for loop now for word in words. So words is nothing but this. Okay, it contains all the words, individual words. I'm going to call it, and I'm going to use for loop, and in this word, like for every iteration, the word will be the individual words present here. First time it will be climate, then change, then yes, then so on. Okay, and what I'm going to do is, I'm going to use the conditional statement here. Okay, I'm going to use the conditional statement. If the word is like for every iteration, it will take one word, right? That word not in, okay, it should not be in stop. Okay, if it is not there, I'm going to use that. Okay, I'm going to append in new, append the word. Okay, else it will be left, and once it run, we'll be having it present in the new. I'll run this. So what will happen is, this, like for every iteration, first time it will be climate, and it will check whether it is not in the stop words. It is not, so it will append it. If it is there, it won't go inside appending, so it will like terminate. So it will take the next one. So let us print this new and check what is there, present there. I'll print the new list. So this list should contain the words which are not present in stop words, like climate, change, one. All the is, was are removed. Unnecessary repetitive words have been removed. Okay. This is how we can create tokens and use stop words to create that. And finally, what you can do is, if you want to combine them into a sentence, then you can go on with, let me create a variable new underscore sentence equal to, I'm going to create a space dot join, so this will join the strings. Okay, dot join, which is present in new. I'll run this, so it will leave a space and join everything. So let's print the new sentence. So the list now will be in a sentence format, in a combination of a single string. Okay, climate change, one pressing issue, so on. Let us see about little bit about working with a regular expression. We may need it when we are going in with projects. So let us see about a little bit about working with regular expression. So what is a regular expression is, they are like commonly abbreviated as regex and a powerful versatile tool. So it is commonly available in all programming language. And what it will actually do is, a regular expression is essential to find patterns of characters. Okay. So you can set some certain rules, it will find that pattern. If it is available, then it will detect and you can do process on that if it is found. So with regular expression, you can search for certain patterns. Okay, you can replace it or you can do whatever you want. So there are like certain rules, like you can specify what is the pattern you are going to find. So like for example, you are doing like control F, right? So in systems you will be using control F, it will help you to find, right? Similarly, this regular expression is like you are not giving directly exactly everything. You are setting some pattern with keywords. There is certain keyword, see here. If you are going to find a combo, so combination, then you can give it inside square bracket. Okay, anything matches between this can be given in square bracket, and you can give the boundary If you want to check for like small letters and capital letters, the alphabets you can give like small A to Z and capital A to Z. If you want to match anything is a character, like there may be A to Z or any lower or uppercase or any numbers between 0 to 9, then you can give /W. So it will leave all the spaces and find all the letters present. So you can use like plus for additional checking. If you want to match, like this is for example checking a Gmail ID, you will be having @ symbol. So you can search like giving, and what we'll just do a little bit example. To use regular expression, you have to import it. It is already available in your Python. So import RE and give the pattern. So you can store a pattern, give it in a string. And like I'm having a sample text here. See here, ABCD in the small letters and then capitals and then numbers. If I want to find these things, I should give the pattern. I can give it inside square bracket, and the pattern I am storing is small a to z. So this will detect this, and capital A to z will find these. And giving the number 0 to 9, so it will find this. So to find all these things, I am giving this, and you have to call re.findAll, so it will find the pattern, and the text you have to pass, so it will find the pattern in this text, and you can print that also. Or else if you want to replace them with something else, you can use for loop for that. Okay, and you can go on with re.sub, so this will substitute the pattern with some specified word. So if I need to convert everything into zeros, and then if I pass text, it will replace that. We'll try to do this in Colab. Import RE, I'll run this. Okay, now what we are going to do is we are going to set some pattern equal to, so I'll open this square bracket, I'll pass it as a string, and inside I'm going to give A to Z 0 to 9 and text equal to, so based on the text only you have to give, but I am showing you an example. So 1 2 3 okay, I'll have this. Now we are going to find it with the help of RE. I'll store it in X, re.findAll. I'll pass the pattern inside and text inside. So let's print X and C. So these are the patterns which are found. Okay, detected individually. So if I remove this number, it won't detect those numbers, only it will find for small and capital AZs. So we will find all this pattern. For this pattern you will be getting only all the letters because I have removed the numbers from that. You can substitute it also. For Y in X, I'll substitute all the letters with zeros. So for that I can call re.sub, store it in a sent variable, replaced re.substitute. I can pass pattern. I need to replace it with zeros, and I need to do it in text. I'll run this, and you can print replaced, so you can see the difference. So I'm just passing all the text only, I'm just replacing them only. See here, wherever there is a text A to Z, a small or capital A to Z, those things have been replaced to 0 and the remaining things are unaltered. This is how you can use or find RE regular expression. You can practice them using in browser regular expressions. You can go to these websites where you will be having sample text. You can give it and search. So you can use this /D, /D. So it will find any digit, and if it is a capital D, it will find all the letters. So you can work on it. These things may be useful. These things can be useful when we are doing searching. Stemming. So stemming is the process of reducing a word to its base or root form, which allows us to find the variation of a single word, and we can treat that as the same word. For example, the stem of the word running or runner or runs is run. Okay, that is the stem word or base word. So you can find that and you can treat the word as same in your sentence. But the problem with stemming is stemming may not always be perfect, which means it can return a stem word which is not even a word, whatever a real word, And for example, the stem of the word was is wa, and it is not even a real word, right? This is the problem with stemming, but you can do it. We'll try to do stemming. There is another thing known as lemmatization, where it will return a perfect word and it will find the base word. We'll try to do stemming first and then we'll move on later with lemmatization. To import this, we have to do from nltk.stem, import porter stemmer. It is a class, create object for it and then use it. Okay, we'll use this. Let me call from nltk.stem, import porter stemmer. I'll run this. So I'll create an object for it, stemmer equal to porter stemmer, and run this. So now what we are going to do is we are going to use these things. Okay, I'll just copy it. I'm going to use that. So I'll be stopping, like we'll create a new list. I'm checking for, like I've splitted it into words and I'm passing this one by one, and I'm checking whether it is not present in stop word, and if it is not present, before appending it, I'm going to pass it inside porter stemmer, where I'm going to create a variable stemmed word. I'm going to stem it and then I'm going to pass it. Okay, in this I'm going to call the stemmer dot stem. Okay, inside this I'm going to pass the word. So this word, if it is not present in the stop words, it will be passed into this stemmer, where it will get stemmed, and then the new word will be appended here. I'm going to pass the stemmed word to append here. So if I run this now, in the list new, I will be stored with stemmed word and the stop words also removed. See here, some words are not complete, climate change. Okay, some are complete and some are not complete. It is trying to find the base word. This is what known as stemming. This is the stemming process. And similarly, there is something known as lemmatization. So lemmatization is the process of reducing a word to its base form called a lemma. And the lemmatization is similar to stemming, but this produces a valid base form, so it can be found, it is a real word. The output of a lemmatized word is a lemma and it can be found anywhere. It is a real word. It will try to find the base word. To do lemmatization, you can call from nltk.stem, import wordnet lemmatizer. From nltk.stem, import wordnet lemmatizer. Okay, I'll run this. I have to create lemma equal to wordnet lemmatizer and run this. So now we can use this. We'll do the same step, and without stemming it, I'm going to lemmatize it now. Okay, so I'm going to call, remove this, lemma word equal to, I'll call lemma dot lemmatizer, lemmatize the word which I am passing in, and I am going to pass this to append in the list. Lemma, I'll run this. So it's done. Now we'll print new and see what is there. See here, it will try to find the base word, and some word will be converted and it will be an entire complete word. Climate change one, pressing issue. Okay, so it is a lemmatized word, so we can see that. Okay, and next, after these processes, lemmatization process, where it will convert them into a base form, we will move on into bag of words. Okay, what is bag of words? So bag of words is a simple text representation technique used in natural language processing to convert text into numerical format. So this is the actual place where we will be converting them into numerical format. Till now what we have done is we have taken the raw paragraph, we tried to do the pre-processing stuff, okay, removing the unwanted thing, finding the base words, keeping it clear. So now we will be converting it into a numerical format. Okay, and this bag of words can be done with the help of count vectorizer from scikit-learn. In the previous module we have seen and learned about scikit-learn, right? And an additional feature from scikit-learn is from sklearn.feature_extraction. In this dot text you can import count vectorizer. Okay, there is something known as count vectorizer. So what this count vectorizer will do is, this will convert them into numerical format, and then later on what you can do is you can give that to the machine for machine learning stuff. Okay, this is what the process of bag of words is. We'll try to do this in Google Colab. First, let us convert this back into a sentence. So we already done that. New underscore sentence equal to, I'll call this, okay, I'll leave a space, dot join the list new. So this will be now converted into a paragraph format, back and new sentence. Let's see what it is there. And you can see all the stop words have been removed, and we are trying to lematize it, and the output, now we are combining them into a single paragraph. Okay, this is the result. Now what we are going to do is, we have to convert this into numerical format, and to do it we are going to use count vectorizer from sklearn. From sklearn dot feature underscore extraction dot text import count vectorizer, create object for it, count equal to count vectorizer, so now we are ready to go. But before giving this directly, you cannot give this entirely to the count vectorizer. You have to split this into sentence and then give that. So what I am going to do is, I am going to pass this again into nltk.sent underscore tokenize. So the new sentence which is stored here will now convert them into tokens, in sentence tokens, and then stored in this variable. So this new sentence will be a list with all the words, okay, all the sentence as its element. Let's see it. Okay, it's already present, so I cannot write here. Since we already convert them into sentence, we cannot do it again. You can print it here. So you see here, it is converted into, each sentence is now element in a list. Okay, and we are going to pass this to this count vectorizer. I'm going to call, I'll create a variable equal to count.fit underscore transform. Okay, I'll pass this count inside. I'm calling this count vectorizer fit transform, and I'm going to pass new underscore sentence. Okay, the sentence here in list format, I'm going to pass this, and what I'm going to do is, I'm going to directly convert them to array. Let me run this, so it will fit and transform it. We'll print and see what this numerical format is now. See here, it is zeros and ones, and it is in numerical format or text. Each sentence is now converted into this format, and this can be converted into a data frame and then given to the machine. You can select the outcome if you are going to do some process, either zeros or ones, and you can do the process. Similarly, like bag of words, there is something known as TF-IDF vectorizer. Here there will be having zeros and ones, but in TF-IDF vectorizer, why we are using it? It is similar only. The TF-IDF full form is term frequency, inverse document frequency. It is a technique used in NLP to reflect the importance of a term in a document. So what is the importance? This will find, and how it is doing is, the term frequency is a measure of how frequently a term appears in a document, and the inverse document frequency will be the measure of how rare a common term, okay, is across the entire document. Finally, what we will be finding TF and IDF, and the product of both will be the final answer. So to do this, you can call from sklearn.feature extraction text import TF-IDF vectorizer. So we will use that also from sklearn.feature extraction text import TF-IDF vectorizer, and TF equal to vectorizer Now it's fine, and we have loaded the object. Now we can use that. So let me create a variable tf result equal to tf dot fit underscore transform. Okay, and inside I'm going to pass the new sentence we already stored. It is a list with sentences as element, and let's fit transform this, and we'll print we'll also convert them to array so that we can use it. We can convert them into a data frame and use it later, and print this tf result. Using this, we'll get the term frequency and inverse document frequency product, so we can find what is the importance of each word. Okay, we'll be getting a numerical format. Then you can convert this into a data frame and give to the machine for further steps. This is how we can use tf idf and count vectorizer